Welcome to Module 3. In this module, we'll be talking about nutrient stewardship and then also some of the transformations that happen in our fertilizer materials, so our nutrient cycling. In the previous module, we discussed organic matter and some of those microorganisms that kind of enhance that nutrient cycling. All right, so kind of the basis of nutrient stewardship, at least towards our environment, is going to be what we call the 4 R's of nutrient stewardship. And so you'll hear this often, especially when we talk about these best management practices or BMPs, so that we can optimize our yield and while minimizing the amount of inputs that we put into the field. And so the 4 R's of nutrient stewardship are applying the right source, at the right time, at the right rate, and in the right place. And so each one of these different components impacts this kind of circle, this social circle. We have the economic circle and the environmental, such that we don't want to over-apply our fertilizers because that's going to cost us money. We also don't want to waste our fertilizers because that's going to harm the environment. And then all of these right here ultimately play back into the social aspect, and kind of why we want to shift the focus off of ag for what they may consider us to be the cause of the environmental pollution. But if you remember from the graphic before, we're like 9% of the carbon dioxide output and compared to industry and transportation and some of those other ones, but they're pointing the finger at us. So we need to be kind of aware of that, and we need to make sure that we're not over applying our fertilizers. So kind of the goals of nutrient management, obviously we're trying to bolster our plant production, or we're trying to increase yield. We've been given this task of increasing yield with less resources, less fertilizer, less water, less space. All of these things are really kind of driving us towards making sure that we properly manage our nutrients, or what we will call nutrient use efficiency. And this really ultimately comes down to nutrient budgeting, right? And so if we're not profitable, then we can't produce food anymore. And so we have this balance between our inputs and outputs. And this is really no different than what we would consider with maybe going shopping. So we need to know what's in the refrigerator, what we have in the pantry before we go to the store, so that way we don't overbuy or overapply in this particular instance. And then finally, that we want to make sure that we're maintaining the soil quality and productivity, that we're not driving our soils faster than they need to be, or there just can be a lot of negative effects if we continue to apply synthetic fertilizers compared to if we can find a way to let the soil kind of do what it's supposed to do. And so that's kind of where we have this shift towards sustainable agriculture, in that we want to get away from synthetic fertilizers and allow the soil to just do its job. With that social aspect and environmental quality, obviously we want to leave something. We want to leave a better environment than when we found it or when we acquired it for our future. We're going to have a big issue with water quality and quantity. And so we have 2 terms that we use. We have point source pollution, which is clearly localized. This is, we can walk up to this pipe. It's typically a pipe where, we can clearly see that the pollution is coming directly from this particular spot. But for agriculture, we have non-point source pollution because it's not easily identified. Now it's easily recognized. We know that if we put a lot of fertilizer on our field and it's at a 6% slope and the water runs down, then we can kind of guess or pretty much recognize that the pollution is probably coming from that field. But it's not like you can walk up and clearly point that it's right here. So throughout this, we want to develop a nutrient management plan. This is why we take soil samples. This is why we're planting cover crops. This is why we are trying to figure out kind of how we can minimize inputs and maximize output. Ultimately, so that we can promote environmental stewardship. So some of those best management practices that we can do in order to promote environmental stewardship or environmental quality, we're going to want to put cover crops down. And we kind of touched on that a little bit in the previous, when we were talking about the universal soil loss equation. So having something on our fields, having something that is going to minimize that rainfall, having something that's going to allow water to infiltrate the soil is going to improve the quality of our soil. Next, we talked about conservation tillage. And remember that we need to have at least 30% of our land covered in residues in order to be considered conservation tillage. Now in Tennessee, we typically do not till. So pretty much most of the land is going to already be under conservation tillage. So like we're already doing some of these best management practices, right? Like this isn't something that we're like, oh, you know what? That's the reason why I am not getting the yields that I want. Like because I'm not, practicing conservation tillage. So we're going to need to find a couple of other additional management practices that are going to improve the quality of our soil. And next we have buffer strips. And so buffer strips are important in that they will slow the movement of water. They will adsorb some of those nutrients that are in the water in that runoff. And so that we can also slow that movement of water so that the soil will settle out before it gets to our stream. Remember that soil is one of the major pollutants that we have considering water quality. Next, we have forage stand management. And this one's huge from a kind of 30,000 foot level. And that if we don't have trees, then we don't have anything to intercept that water. We don't have anything to, trees being able to pull out a large amount of carbon dioxide out of the atmosphere and replace it with oxygen. So when we remove that, when we cut down trees, we're taking out a large positive part of our ecosystem. Just to look at some of the cover crop benefits, and we sort of touched on this previously in when we were talking about that carbon to nitrogen ratio, and where we have mineralization and immobilization. And this is also, I want to make sure that you pay attention to this as we move into the nutrient cycling or into the nutrient cycles, because each one of those nutrient cycles has immobilization and mineralization. So when we have a low carbon to nitrogen ratio, we can expect to have a net mineralization. We're also going to increase our organic matter. And remember that organic matter plays a large role in for several things. For CEC, for water holding capacity, it's going to help our soil stability and structure, infiltration, things of that nature. And so because we have those plant roots that are constantly growing, when those channels or the roots inside of those channels decompose, they leave openings, and those openings allow water to move into our soil. They're going to be good for weed suppression, and then ultimately, kind of one of the main goals, at least from a production standpoint, other than the benefits that we get for our soil stability, is going to be applying less fertilizer. And so because of this low carbon to nitrogen ratio, and we get a net mineralization, or we actually get a nitrogen credit because we grew these cover crops. So we'll plant cover crops in the cool season, typically around September. We'll allow those to grow over the winter. They will kind of hold our soil in place and absorb some of those nutrients. They'll scavenge some of those nutrients from the soil over the over the fallow season. And in the spring, when it's time to plant our cash crop, we can terminate those cover crops, and that all those nutrients get added back to the soil. So they're kind of like a safety net that kind of captures some of those things that we might have lost to leaching or percolation loss because we get a lot of rainfall in the wintertime. So just to look at a few of the most common cover crop species that you'll come across, we have ryegrass, crimson clover, vetch, and alfalfa. And so this table is showing you kind of what the carbon to nitrogen ratio is and what you would expect if you planted some of these cover crop species. So for our grasses, we're going to have about 25 to 30 to 1 for a carbon to nitrogen ratio. And this is going to be about neutral. You know, this would be, you're not going to get a large boost of mineralization, or you would not expect a large amount of immobilization. So kind of in the middle. Remember that our ideal microbial diet for carbon to nitrogen ratio is 25 to 1. Now, if we start planting some of our grains as cover crops, then we're actually going to get a net immobilization. And so because they have such a high carbon content, the microbes need the nitrogen that is in the soil in order to decompose some of these materials. And then down here, our legumes have a very low carbon to nitrogen ratio, or CN ratio. And so because we have a low CN, then now we can expect to have a net mineralization, or we would actually get a nitrogen credit. So when we plant these types of cover crops, this is where in the spring, when we terminate them, we actually get a nitrogen credit. So you can kind of think about this as like, let's say you need 100 pounds of nitrogen for your crop. You plant these cover crops, and in the springtime, when you terminate them, let's say you get a 30-pound nitrogen credit. Well, now you only need to buy fertilizer for 70 pounds of nitrogen per acre compared to 100. And so by doing this and building that nitrogen content over time, over years, you'll need to apply less fertilizer. So we, again, going back to conservation tillage, we need to keep at least 30% of that cover crop, or at least 30% of that soil covered. This video kind of gives you an idea of what a strip till would look like. And so if you can imagine a tiller that goes all the way through the field, we're going to plow this field up and it turns all the soil. Well, a strip till only tills in the row. And so, this is kind of geared more towards row crop, in that there's going to be a basket on the back of this tiller that only kind of tears up just where you're going to plant that seedling. All right, so for buffer strips, this is just kind of something that is, giving a little more time for that runoff to slow down, and that we can, slow that water. And remember that when runoff intensity exceeds infiltration rate, or when rainfall intensity exceeds infiltration rate, we have runoff. And so if there were no buffer strips here, the water would run very quickly into this water body, carrying with it the soil and the nutrients and all the other things that would actually pollute this. So if we have something in between where we are cropping and our water body, we will slow the movement of that water. These plants will also take up the nutrients that are in the water. We will get more infiltration, and whatever does make it to the water body is now actually a little more purified. Again, just to look at different components of buffer strips. And so sometimes we'll get this infiltration, and as this water moves into the soil, we will get adsorption. We'll have some of those, some degradation. But basically, if you remember all the way back from like module 1, we talked about that soil is a very good filtration system. And so this will kind of clean. Think about soil as like a brittle water filter, in that we will remove some of those chemicals, or the fertilizer, the nutrients, and then that water will then move towards the water bodies. It's probably better shown here. In that when the water infiltrates the soil and percolates through, it will eventually make its way to either this water body or ultimately all the way down to the water table. All right, so next we have forest stand management. I think this one's kind of a no-brainer. Like we know that when we remove trees, we're we're certainly not helping the environment. And so we want to make sure that we're keeping those trees, especially on tops of hills, because remember that if we remove all of this cover, we get no interception now. And now we have raindrops hitting the soil at 18.5 miles per hour. We get detachment, transportation, and deposition. And that deposition is going to be in our water bodies or somewhere not where we need that soil. So some of the things that we're going to kind of want to make sure that we're aware of as far as losses for forest stand management, leaching and runoff, probably more so on the runoff than we have the leaching. And that's going to erode our soils that contain those nutrients. Also, one important component that we just kind of can't get around for forest stand management is going to be volatilization. We need to have controlled burns in order to manage our forest systems. And when we burn things, there's going to be something given off, right? The smoke, or there's going to be some volatilization of some of those chemicals that are in the soil that typically wouldn't be released into the atmosphere unless they were burned. So obviously we're going to want to minimize that soil disturbance. This kind of goes all the way back to that regenerative agriculture thing. And so, sometimes some of the practices that they do that are probably more efficient as far as the work aspect goes are probably not good for minimizing that soil disturbance. And then also that we want to use selective cutting instead of clear cutting. And so there's probably a good portion of thought process that goes into which trees we're going to cut down so that we can be sustainable when we are harvesting our timber. Because, timber is a big business, but we can't just harvest everything. So ultimately, these 6 core principles of regenerative agriculture, and if you remember from one of the very first things that I said about it's not, for me, it's not so much about the regenerative part as this is just like very good best management practices to at least be sustainable within your system. And so, the regenerative agriculture comes from when we add these livestock. And so we're not just going to be grazing cattle on the top of a hill in our forest stand, in our forest stands, right? All right, so that's going to end this little portion of Module 3.1.1, where we talked about the kind of some of the best management practices for environmental stewardship. In the next module, as we move into the next module, we'll kind of get into those 4 R's. Remember those 4 R's being the right source, at the right rate, the right place, right time.